Our session back in May, Green Building Product Certifications by Building Green, touched upon LCAs and EPDs. LEED 2012 will incorporate LCAs in the MR credit requirements. Thus, this topic is relevant to tomorrow's designers and spec writers. Rick Master will now discuss the subject in detail.
I'm going to first try to describe a little bit about what I define LCAs as. And obviously, being an architect, we have to do graphics. We can't do any text. So this is my attempt at trying to define what LCAs are. It's basically everything that goes into the production of a construction product to everything that comes out, whether it's a negative or a positive impact. A lot of people say cradle to grave or cradle to cradle would be the whole study of all those inputs and outputs through every stage of the product life, meaning extraction of all the raw materials, manufacturing, transportation at various modes, service life of the material and the building, and then disposal or recycling or reuse of those materials. If you look at the yellow box, that's cradle to gate, and that means before service life and removal or reuse. And that's really where a lot of the products would be evaluated. If you did not evaluate the pollutants or the impacts on the environment and just studied the energy, that's what's commonly referred to as embodied energy or primary energy cradle to gate. And that's where a lot of comparisons have historically been focused. I'm going to use some examples. You know, everyone asks, is it better to use a paper bag or a plastic bag? Well, there's so many different values about that. And the only way to make, as far as I'm concerned, and as it pertains to us as spec writers, intelligent decisions are what we're really focusing on. We need to know some background. We need to know some information. So, well, what do we need to know? Well, we need to know, you know, where did the plastic bag come from? The good news is over 56% of all paper in the United States is recycled. Where does the plastic come from? You know, is it going to be recycled downstream, upstream? Most plastics can't be reused in the same product that they were originally if they're recycled. So that usually is downstream. But then there's also bioplastics. So if it's made from a bioplastic product, that changes the whole life cycle impact of that material. You know, where did the paper come from? Was it coming from raw wood, et cetera, et cetera? Really the answer is if you're using the bag once or twice, paper is a better choice. If you're using it many times, if you reuse it over and over again, the plastic might be a better choice. But the real answer is a reusable bag is the way to go. And so, you know, that's used multiple times. Might be cloth-based. It might be something else. So that's the way you have to look at LCAs. How does this pertain to building products? We'll discuss that. I'm going to talk a little bit here about what an LCA is. It's basically the embodied energy plus the durability of the material, and I'll talk a little more about that later on. And then, of course, as I said, all of those impacts, the negatives and positive environmental aspects. I'm not going to go through every one of these slides to this next group because they're just basically definitions of the environmental aspects, but I have them in there in case you wanted to download the presentation and see what I was interpreting them as. But it's important to understand the ones that are important to you. They may not all be important to us as specifiers and architects. Global warming, obviously the carbon footprint, a lot of people talk about that. I'm not going to go into all of these. The ones that seem to be most commonly used are the global warming, acidification, human impact, of course. Some cases fossil fuel depletion, but not in most cases. But that's already picked up in primary energy or embodied energy. Material depletion, there's some definitions for different types of categories of materials based upon how much is available. And the one I really like is water depletion. There's quite a bit of studies done, which is if you wanted to do a search sometime, you had nothing to do, check out virtual water. It studies how much water is used to make materials. And certain countries have little water and some have a lot. So, you know, being an environmentalist myself, I drink beer because it only requires 75 liters as opposed to 140 liters of coffee. So, you know, you should use your studies for good causes.
Do you have that beer in the morning, Rick?
Well, if you notice, there was tea, which is 35, so I drink tea in the morning. But it's a valid question. This is just a non-graphic representation of that embodied energy study. Again, we're going to focus mainly on cradle to gate. There's too many variables in the service life of a lot of materials, and really I don't think anyone's got a handle on how long materials last, and so there's a lot of questions in that area. This is a study that's been done, and again, you'll notice that it's energy per mass. So aluminum is extremely energy intensive, as opposed to something like brick or drywall. Here's a carbon footprint of nylon carpet, and what's interesting is if you notice that 61% of the carbon footprint is during the extraction, a heavy carbon burden there. It would be better if this was energy related, but carbon and energy usually are somewhat closely linked. So in theory, you might be able to save 50% of that carpet by recycling carpet. And in fact, there are a lot of studies out there that talk about how much energy you could save. I converted that energy into miles that a 30-mile-per-hour vehicle could travel, and that's why you can see with 1 ton of aluminum, you can save enough energy to drive a car 10,000 miles. That's unbelievable. And then you can start looking at some of the other reductions due to just saving of energy. What's interesting to me is less than 50% of all the aluminum used in the United States is recycled. It's a pretty sad fact. Newsprint is the #1 product recycled in the United States. If you recycle 1 ton of bricks, you can drive 13 miles. That's all the energy you're saving. There are other reasons to recycle, but instead of recycling that brick, you might have been able to reuse it. Much better use of the environment. And these is just that same slide showing some of those impacts. But maybe you should be looking at materials from a property or performance standpoint. Here's a nice little study that it's not per mass necessarily. There is a energy per mass on the bottom line, and it shows glass having the least amount of energy per mass. But do you need as much glass, mass-wise, as aluminum, for example? So the next study shows per volume of containers. So, and what's remarkable to me was that the steel can was actually the best from an environmental standpoint. And that was sort of shocking to me. I had no clue that that was the case. I knew the reason that we stopped using glass was mainly because the aluminum can didn't break, and you know, even though you're only using it once, I was really shocked to find out that that actually had the highest environmental impact. This is a study that was done by the Athena Institute in Canada, and they actually did it per system. So they took and constructed a system and then gave you embodied energy and carbon footprint of various systems. So you could take a stud wall 16 inches on center with drywall on both sides, and you can see what that impact is in comparison to, let's say, a wood stud wall with drywall or a 6-inch concrete block. Now we're starting to get into comparisons where an architect can understand the rationale. If you would have taken that per mass, the numbers might have been totally off, and you might have found out that in that case the brick was actually less impacting, but you're not using that much mass in the stud wall and drywall assembly. I probably know more about drywall from a material standpoint than I do most other materials, but we've done quite a few LCAs here on drywall, and we first need to know what is drywall. It's basically just two pieces of paper with gypsum in between it, and we use a very small amount of starch, less than 0.5%, and the starch is a natural binder to bind the gypsum to the paper, just like macrame or something like that when you were younger you'd play with. And then there's always miscellaneous additives. There might be glass fiber for a type X, a fire-rated product, or some lightweight aggregates for a type C.
Rick, if I may, these studies done for virgin gypsum or FGD, or does it matter?
It does matter. I will talk about that a little later. Okay. I don't know that I did a direct comparison, but I do have that information. So again, it depends on distance, but we'll see that, I think, reflected in some slides later on. And if I don't bring it up again, please do, Richard, bring it up again. Okay. First off, we need to know what gypsum is. It's calcium sulfate, 2H2O. It actually holds about 20% of water by weight. That water by weight is actually more like 60% by volume. If you've ever played with plaster of Paris, that was just dehydrated gypsum, and if you add water back to it, it gives off heat and turns back into gypsum. It's the only mineral that you can continuously heat and add water to, and it goes through a complete cycle. It never loses any mass or properties. If you over dry it, you get what we call dead burnt gypsum, and it's actually Keen cement. Keen cement is an interior product because it is gypsum based. It should never be used in an exterior of a building. Gypsum is a cement. It's just not Portland based. It's naturally found. There's also recaptured or recycled gypsum that's being used throughout the United States. It's a very abundant material. It's the second most common mineral in the world. It's actually found all over the world. I'm sorry?
Second to what?
Second to silica.
Okay.
Sand. It's found all over the world. The largest open gypsum field is White Sands National Park in New Mexico. Obviously, no one mines that material. It's actually the peninsula of Nova Scotia is 100% gypsum. There's islands in the South Pacific that are nothing but gypsum. Recaptured or synthetic, Richard asked about, is really usually named for the process that it is chemically made. I don't personally like synthetic because it truly is a chemical gypsum. It's chemically identical to natural gypsum. And it's basically just taking limestone in a misting format, and it chemically binds with sulfur dioxide and produces calcium sulfate. You add water. It also off-gases a little carbon dioxide in the process, but it actually captures over 90% of the sulfur dioxide that used to produce acid rain back in the 50s and 60s. That gypsum used to be made at every coal power plant. The higher the sulfur in the coal, the more gypsum that it would produce. There's about, as an average, 0.6 tons of limestone to produce 1 ton of gypsum when it combines with that sulfur dioxide. It's drastically reduced acidification to the point where farmers now actually have to add sulfur back to the soil because they no longer get it from the dirty air that used to, when it rained, brought sulfur back down to the soil. It drastically reduces transportation because most power plants are built near cities to produce energy for their use, and most drywall needs are near cities where there's a lot of construction. So we usually build our gypsum drywall plants next to power plants. Very little transportation in most cases. It reduces our raw material extraction and expands our life of our mines. But it does increase some greenhouse gas in the form of carbon dioxide versus sulfur dioxide. So one versus the other, and actually sulfur dioxide is probably a worse greenhouse gas than carbon dioxide. Another byproduct of desulfurization of coal power plants is fly ash. There is no fly ash in drywall, at least gypsum panels. There's fly ash in Portland cement, usually as an additive. I'm showing this because a lot of people have a hard time understanding why they can't get synthetic or recycled gypsum in different locations of the United States, mainly California. There is no coal power plants in California. I'm not suggesting by any means that California builds a bunch of coal power plants and ships a bunch of sulfur coal there so that they can produce a byproduct for us to use in making of drywall.
Do you have a color key here? What these colors mean?
Yeah, the darker blue would be I believe is the second largest. The lighter blue is the largest states. So you'll notice along the Mississippi Valley, Ohio Valley, are the most power plants per state, if that makes sense. The grays are the second least, and then the red is 0, the states that have 0 power plants. And this map shows where all the high sulfur coal is along the Ohio and Mississippi Valley. Just sort of interesting that if I go back, those blue states and where all the coal is located are sort of overlay each other. The interesting facts is in the Rocky Mountains, and we'll go back one again, where a lot of the grays states have very low sulfur and produce extremely low amounts of byproduct gypsum, and they actually don't even bother selling that material to manufacturers. They use it as a soil amendment. These are just some stats from the past and present. Natural gypsum by ton was 29.9 in 1990. 2006 was sort of the last of the big production years, and you can see, well, between 2000 and 2006, somewhere around 40 million tons of gypsum was used for drywall. Now there's only 13 in 2010. So a drastic drop in requirements or requests due to the reduction of construction. And if you look at the total market needs, you know, it's 46 versus, or 57 versus 27. So that's what I'm trying to say here. But flue gas desulfurization has increased drastically to 50% of the current production is made with synthetic or recaptured. Very little recycled, and I can explain basically that for several reasons. One is it depends on when the material is coming from. Anything pre-1980 is not allowed to be used by the EPA regulations because of potential lead paint or asbestos contamination. There was never asbestos in drywall, at least not ours. I did read somewhere where one of the other manufacturers did say they might have used some in their production, but it was used quite commonly in the field as an additive to plaster, veneer plasters, or joint compounds. Here are the impacts, and this is 100%. So when you're looking at these bars, the scale has nothing to do with the amount. It has to do with the breakdown at various stages. So the first sort of reddish section is the raw material extraction. The green one would be then the transportation of those raw materials. The purplish is manufacturing of the material into drywall, etc. Manufacturing obviously has the largest impact. Primary energy, smog, global warming or carbon equivalency is the bottom one. So you can see manufacturing definitely has the most impact. Here is, I have a lot of people that constantly ask, can you ship drywall made in East Chicago to California so I can get a LEED credit, because we don't have any synthetic or recaptured drywall. So our drywall in California is much lower recycled content because that byproduct gypsum qualifies as a post-industrial or pre-consumer material. And I like to show this because I'm trying to show the environmental negative impact from an embodied energy, and carbon actually would be much higher because of the transportation. Carbon is higher because of truck versus rail impact.
You haven't actually done that, have you?
I have.
You
I
have.
have done the carbon impact as well. It's a more dramatic change, but I just like to. I mean, I think the embodied energy is enough to show people that this has a drastic negative impact. And to just go for the credit really is not the right thing to be doing. So I guess I didn't show the comparison of synthetic versus natural, but I did in the slide before. If you read the bottom, the primary energy of extraction is less than 8%, or 10 miles. So synthetic, even though there's a lot of positives, it has a very little impact on the overall impact of drywall. And it varies from plant to plant, depending on where the raw materials come from.
Okay, Rick, so how do you see the synthetic in that graphic that you have up there now?
Well, you would take out that first reddish bar.
Yep. And
that's where you would basically. Right, you would just, it would be the green, purple. So you would basically have a less impact based upon that percentage.
Right.
And what I really want to show is that when I'm talking about these, and those graphs make it look like they're very large, they're really extremely small impacts. Number 16 here is interior gypsum board. This is a study that I didn't do, but I mean it was very comparable to studies that I've done. And so I tried to use other people's documentation to show basically what I'm trying to say here. The energy and the carbon equivalency or global warming impacts of drywall manufacturing is extremely low when you start looking at other materials. And that air pollution index is basically smog, so the NOx. So what I did is I took an Athena report on half-inch plywood and compared it to the Athena report on 5/8 gypsum board that they did for us. And I'm showing here the global warming. The drywall is the yellow, and the half-inch plywood is the brownish red. Global warming or carbon equivalency is the first one, and you can see the other impacts, smog being the last one. Again, look at the smog on the other chart behind it, so you can get some kind of a metric comparison. And then if you look at embodied energy, that's where the big difference is. The embodied energy or primary energy of plywood is considerably higher than that of gypsum board. Now, again, plywood is relatively low, so I'm not bashing plywood. I'm just trying to give you an idea. I told you that the manufacturing of drywall is the biggest impact. The kilns that dry water out of the manufacturing of drywall only run at 300 degrees Fahrenheit. So you compare that to something like float glass, that would be several thousand degrees to melt the sand. The energy used in drywall manufacturing is extremely low. Now, there was someone that was claiming that they had a product that had no or had considerably less energy as a replacement for gypsum panels because their manufacturing energies were extremely low. What they were doing is they were using a Portland cement based product, and all of the carbon generation and all of the primary energy is in extraction. They weren't counting that because they were buying the Portland cement. You have to look at every stage. You can't just look at one window and say, oh, during manufacturing, a Portland-based panel uses a lot or produces a lot less carbon than someone else's. I can't take, for example, if I was doing this comparison for drywall to plywood, I couldn't take only a small window or one stage and say this stage versus their stage is so much lower. You have to do it cradle to gate because that's where you deliver it. So you might have heard about product category rules or environmental product declarations. Those are basically LCAs for a specific product category. For example, drywall, paper-faced drywall, paper-faced gypsum panels, whatever you want, whatever term you want to use. That's a product category versus something like glass-based gypsum panels. That would be a different category. And so there's different rules for each product category. Without those product category rules, you really can't establish fair comparisons of materials. The other problem that I have with LCAs when you're trying to compare one product to another is there's no established standard for determining a service life. Someone said that they did an EPD on a acoustical ceiling tile, and I asked what was the service life according to their study. They assumed it was 60 years. I said, I've never seen a ceiling tile that has been left in a building 60 years. I'm sure there is, but I just know that most ceiling tiles, even though they don't need to be changed out, are changed out for aesthetic reasons. Is that a fair service life? I don't know. I know for a fact, for example, plaster performs better than drywall does with a service life. It doesn't get indented as much. Basically, the difference between the two products is gypsum panels are aerated gypsum. Plaster is not aerated, so it's much tougher. And gypsum panels have paper on the surface. The paper rips, the paper's it's scratched. I can't believe those two should have the same service life. The other issue with a lot of EPDs and LCAs is that they have no way to regulate what's the impact on the occupants' health and well-being. How does that affect them from exposure, from, are there chemicals of concern within the products or added to the products? Do they give off VOCs or even formaldehydes, which may not be classified under the definition of VOC since it's only carbon 5 through carbon 16, and formaldehyde only has one carbon molecule. These are all things that need to be worked out. And then think about this. what if you were comparing rigid insulation to, let's say, drywall? The drywall will have a much lower embodied energy, but the rigid insulation doesn't get credit for the reduction of the operational energies over the life of the building, which could be drastically a much greater savings than the negative little bit of embodied energy that it costs to produce. So those are things that have to be considered. So I mentioned chemicals of concern. If you haven't heard about some new credits, the lead EQ TAG, Technical Advisory Group, is looking into chemicals of concern and how we just ask for disclosure of what's in materials without asking to give away trade secrets. What we're really looking for is we want declaration of some chemicals that might be contained in the product, and we want then risk assessments on how dangerous those, even if they're trace elements, those elements might be for occupants and well-being of the occupant.
Rick, are you referring to the so-called red list?
Red list is one, yes, by Farrows and the Living Building Challenge. As a matter of fact, I talked to them quite a bit, and actually that's a very nice lead into this slide. I explained to them that there's mercury in everything found on Earth, found in the air, water, soil. Matter of fact, I was talking to them, and I told them that the water they were drinking had more mercury in it than most building materials. There's trace mercury in concrete. There's trace mercury in every gypsum, every rock found on Earth, and every vegetable that grows on Earth. And you can go to the EPA's website, and they have some great information about mercury, lead, a bunch of other things. So there are a lot of trace elements that you're going to find on that red list that are going to be in every building material. So at first they said avoidance. They didn't want to have any building material that had any of those red list elements. And I tried to explain to them that then they don't have a building material that does meet that requirement. If you look deep enough, you will find it. Now, the new direction looks like we're going to have to come up with some low limit, and I guess what I like calling it is a report limit. So if it's below that, you wouldn't report it because the EPA has already defined that it's well below any health risk, no matter what, how do I want to say, sensitivity an individual would have. So it's a good question. The red list is a great list, but we have to be realistic about it as well. We need some constant metric. I really love the nutrition facts. It's a simple way that we somewhat can look at that and understand. I still don't know that I understand which fat I'm supposed to use. I like the ones that taste good, but I know we're not supposed to be liking those. But that's maybe the kind of thing we need from an environmental impact. EPDs, environmental product declarations, are trying to go that direction. They don't have a simple little cheat sheet, if you will, or a label yet. LEED tried to do that with buildings. They're trying to do that to some degree. And I've seen a few lighting companies and some other companies starting to come out with their own little labeling thing and hoping that it'll catch on, but they're still somewhat confusing, and they're not consistent across all building materials. So they may not be able to be. Green format, I think, has a lot of potential. It's not talking about the website as much as I'm talking about the questionnaire. the questionnaire is a great tool for product manufacturers to follow to fill out information about their products. It's also a great tool for us as specifiers, because now each manufacturer might have a similar declaration, and the one section that I've highlighted, it really starts with the LCA or EPD, if you will. So I think that there's a lot of potential in the future for green format being a great source of information or guideline for manufacturers to report information about their products. And that sort of leads me into the EPDs. Europe has really taken off on the EPDs. They're really not real popular in the United States yet, but I think you're going to start seeing them generate here pretty quick. The problem is they're supposed to be industry-based or created. So you create your product category rules as an industry, not as an individual company. And in the United States, we don't have a real good, how do I want to say this nicely, we don't talk much between competitors because of a lot of reasons. We don't want to be accused of setting prices. You know, we just don't like each other. In Europe, it's a totally different environment. It's a lot easier for two competing companies to get together and discuss what their product category rules should be. So what I guess I'm saying is maybe CSI, maybe the end users are the ones that are going to have to stand up and say, this is what I want from every manufacturer. And I want primary energy, I want carbon footprint, I want acidification, I want smog. Those are the four basic ones. And then you decide if water is a concern for the product you're producing because you use a lot of water or not. You decide if land use or something else is an important one. I don't really care. I want those four because now I can compare products to products. So with that, I think that that's basically it. And I will open it up to questions.
I'm sorry, Rick. Can you go back 2 slides? Is that AIA guide? Yeah, next one. Right there. Nope. Forward. Next one. The AI Guide to Building Life Cycle, is that available online?
Yes, it is. At that website.
Okay. Mm-hmm.
That's an excellent document, by the way. Thank you for bringing that up.
Yeah. Very good. And I have a question for you. It has to do with the UL E100 standard for sustainability for gypsum board. Can you talk about that standard?
Yes. That was sort of a industry supported document or standard. It was a method to evaluate gypsum panels, paper-based gypsum panels, for improved sustainability. And at the time that was created by UL Environmental, which is a subgroup of UL, they decided that they wanted to, jump on real quick, push the industry, which is a great goal. And it was incremental improvements. So you would have to show improvements from 10 years ago, 20 years ago in a lot of areas, not only energy reduction, but maybe water reduction, obviously all impacts, so carbon footprint, et cetera, et cetera. And you got credits. It was a weighted, multi-attribute weighted standard. It was much better than having a single attribute standard like VOC emissions or recycled content or regional materials. It was trying to lump all those together. It still was weighted, so in other words, there were some credits that were worth more than other credits. And some people have a hard time with that. I personally do, because I don't know that I want you to tell me which ones I should be more concerned about. I will tell you which ones I'm concerned about as an end user. Since the release of that, I think the direction of everyone is going to be these environmental product declarations that are not weighted. They're industry developed, and I think that they're a better route to go. So I think that you'll start to see ULE actually probably assist various manufacturers in coming out with their EPDs based upon the product category rules that have been established by their own industry. So I hope that answers your question.
Yes, yeah, thanks for that. And did USG adopt that program or run the numbers on it?
We participated. We actually were one of the, I think, the first product that was listed as, achieving one of their,
What level was it?
Well, the lightweight product, I think, achieved gold.
Okay.
I think it wasn't the lowest.
Mm-hmm.
I don't remember. I think silver is their lowest category.
Yeah, silver, gold, and platinum.
And I think that most, to be honest with you, drywall products, meaning our standard sheetrock brand, would probably meet silver, as would gold, Nationals gold bond.
Mm-hmm.
So if that's the case, then is the standard too weak?
Yeah, I see.
Because, I mean, let's be very honest. If you look at the Architecture 2030 for products, most manufacturers, especially in the drywall business and ceiling tile, have been drastically reducing their operational energies, manufacturing energies, over the last 20 years. We have a massive, even though I told you we're not energy intensive, we have a massive project to reduce energy usage.
Mm-hmm.
Because energy is a direct cost, and energy prices aren't coming down.
That's right.
I just got a question in here from Dan Marks asking, how does the industry begin to create product category rules?
Oh.
Well, yeah, according to ISO, each industry, so depending on what product line you're talking about, all the manufacturers, or as many as you can get, should get together. Usually, like in the case of drywall, we have a gypsum association. So all members of drywall manufacturers are members of that organization, or at least most of them. So we would, through the Gypsum Association, create the product category rules for that product line. In the case of ceiling tile, there really is no ceiling manufacturers or ceiling tile manufacturers association. So CISCA, which really is also has members that are the installers, would act as most likely our representative to create that product category rules for us. So that's sort of hopefully that answers the question.
Alrighty, and any other questions? Oh, let's see here. Kathy Stainer.
I got one. I got to add, Matt. I got to add one other thing.
Yep.
It also should always include a representative from the architectural community, the end user, as well as the installers. So you want to have a broad group, not just manufacturers represented. So you should have other key stakeholders as well. So that would be part of the team that would create them and then review everyone's EPD. So I'm sorry for interrupting.
No problem. Actually, that leads into the next part then. Kathy Spainer, I believe I'm pronouncing her name correctly, is asking, do you then see that LCA and EPD is potentially replacing certifications such as FSC?
Well, I do. But forestry goes, in some cases, that's again a very weighted, sort of a very weighted LCA or approach. So I really see EPDs replacing the needs for single and multiple attribute standards. I think that's the best way to say it. And I'm not, I don't know, there's a bunch of different wood associations out there and standards out there. So yes, I do see that replacing that in the long run.
Great. I do not see any other questions. We'll give you guys all a few more seconds to come up with some good ways to stump Rick here. In the meantime, though,
I have a question
yep.
for Rick. You mentioned that in Europe, the manufacturers talk more together. How do the U.S. gypsum board manufacturers do? Georgia Pacific, USG, and the third company skips my mind.
Well, National Gypsum.
National Gypsum.
American Gypsum.
Yeah, do you guys talk to each other or not?
No.
Okay. And do they have someone like yourself who's doing all this?
Well, I mean, it's a small community. Don't get me wrong. A lot of people, you know, I mean, it's a small community. So there are people that talk. And because I'm not in sales, I think legally I can probably talk to them more than most people can. Mm-hmm. But we have regulations against that where Europe doesn't. Matter of fact, Europe has the opposite. They require collaboration. So I mean, there's really not competition there. Mm-hmm. Totally different than here.
Okay. Mm-hmm. I just want to refer back to our May webinar where we had Building Green do their green certifications report review. If people want to get into this in more detail, that's an excellent report. It's called Green Building Certifications Reviews, and it's available through Building Green. And you can also earn, if you're an AIA member, earn learning units. I think there's, you can earn up to 6 learning units by taking a test at the completion of that report. Rick, do you want to add any closing remarks?
I guess I would just say that in closing that it's inevitable that U.S. will have EPDs for, I think, every product category. So whether you know, I mean, I said we don't talk. Whether we talk or not, we will talk. We have to talk. And the best way for us to do that, like I said, is through associations, because then we don't get into the legal issues of whether or not we're negotiating price, which obviously is illegal. And when all manufacturers are very sensitive to that, so at least in the U.S. So
okay, well,
it's a must, and we as architects have the opportunity to make sure that we ask for what we want.
Which we are doing.
Yes.
On these days. Okay, with that, Matt, I guess we can close a couple minutes early. It's just about closing time. Rick, thank you for your presentation. I may myself go back into your webinar to get a few links that you provided there.
And please ask questions. You have my emails. So thank you.